Hey everyone, I guess I'm a bit late to the class. And if you are a teacher, you can't be late to the class. I'm really sorry. So I used to be late in the class in college. I used to be late in the class in school, but this time I'm teaching. So how are you doing, guys? It has started. It has started. Sorry for the delay, man. Sorry for the delay. I had a last time error and I wasn't able to solve this. I guess my my audio and video are working fine. There is no problem in that. Right? Is my audio video working fine? Good evening, guys. Good evening. How are you doing? Excited? I am very excited today. I was excited. It was 7/7 and it was time for the class. So I just heard about that. If you're a teacher, you just can't be late to the class. And again, I made that mistake. Okay. So I guess you got the mail and I gave everything in the mail. I gave the details of the last classes, what I have taught, right? The things I have taught in the last classes. And in the last class, what we were doing big O notation. So if you remember in the big O notation, what I was very much specified upon, that everything depends on the input, the behavior of the input. So everything depends on the behavior of the input, no matter what you do. So the behavior of your input is something which is you have to study the behavior of your input. If you remember this, our time doodle, if you remember this, right? We were studying this. This is, no, I didn't receive any mail. You didn't receive any mail? How did you join the session? Palak, you have registered, right? So everybody who has registered, you guys get the mail of, you guys didn't get a mail from our end. Because that shouldn't happen. That shouldn't happen. Because you would be getting a mail from our end stating that what happened in the last classes and how we are going to do in this program. Okay, cool. You got the mail. Some people got the mail, some people didn't. Okay. So I'm gonna just start in a sec. Give me a sec. My machine is turning up. My machine just failed whenever. Like the moment I was going to start it, the moment I was very ready for class, the moment I was like, yeah, let's do it, and boom, life happened. So in the chat section, guys, can you tell me how many people are actually preparing for how many people are actually preparing for placements? How many people are really trying for placements? So can you tell me how many people are okay? So the last time we did was big O notation. So big O was kind of a notation, or it was similar to SI, or it was similar to, the name is very similar to what we have been teaching. The name is something what we have to focus upon, right? So the name is something, notation. How do we notify things, right? How we were notifying things, how we were notifying a set, a unit. That is the reason we got big O notation with us. So the reason of okay, so there are people who are studying for placement. Okay, you have come to the right place. I tell you, I was very scared when in my college when placements were going on, and that was the stuff. Check BIOS version and update it. This will solve it in especially Dell. Man, yeah, I don't know why this happens. So I have multiple systems with me. The one I am using right now is something which I prefer on my day-to-day basis. It's my daily driver, but it didn't work like a daily driver. It was like undaily driver. So yeah. So I'm gonna share my screen. I hope everything would be visible. And I prepared slides for you. Yes. Okay. कुछ और खुल गया. Yes. What I am going to cover in this bootcamp. I guess I have given the program structure and syllabus. I have provided with you with the program structure and syllabus. It's on the Skillenza website. So if you really want to check the program structure and syllabus, you can go on the Skillenza website and you can check for it. I'm going to cover all the most important parts. I'm going to cover all the algorithms which are needed. I'm going to cover all the general topics which you really need to know. So that is why I'm here for. So today I had a wonderful day. And speaking of wonderful day, today is a really great day in terms of it's a really great day to learn. So I'll give you the according to that day one string and also yes, I remember. So yes, I will cover strings and array today because big O notation took a lot of time yesterday, sorry. So today we are going to cover strings, array, and if it happens, we can extend this program into 5-day or 6-day according to your convenience. Okay. So you remember I told you about the big O notation. You remember, so I would be going blind right now. So I would take some time. It would take me some time after to look upon your comments and look upon what you have been asking. So I'll take some time. Okay. Happy you're here, and let's start. So you remember, if you'll just go to the last class, I told you about different algorithms, right? Different notations which was there. And most of the notation which were very important and most of the notation which came into the use in day-to-day basis. Okay. So you were asking that, Prakarsh, how did you find what kind of notation should we give to equation? What kind of equation? So this is the part where it comes where this comes to play. Okay. So this kind of notation is something for which you have to follow a map. You have to follow a mapping of a notation. For example, for an algorithm. So I really don't want it to take credit on this one. And I really don't want it to, all you need to do is open your browser. I'll just show it, because anytime in life you are searching for something, anytime in life you are thinking of something, that what is big O notation, and if you really want to revise it. Okay, so there is a graph, there is a very famous graph, and let me show you the graph once. Okay. Oh, boom ho gaya. So you understand what is happening over here. I had to open Paint to do this. So this is a graph, and this is the running time in terms of big O, and this is the size of the input, right? I told you that size of the input is something which is very much took into play, because the size of any notation, the size of input size, we had n with us, right? Remember, we had n as our input size, and the running time complexity in terms of big O. So running time complexity is the time which it actually takes to run, And as you can see over here, O n factorial, O n log n. Yesterday, I told you about the different types of algorithms and what is the running capacity, how better it is. So we generally take the whole questionnaire set is based upon the worst case scenario, not the best case scenario. So whenever you're thinking of a question, whenever you're thinking of an algorithm, you have to think of the worst case scenario. You have to think of you have to think of an input. You have to think of a running time complexity, which is going to make things worse for your algo. And for every algo, it's different. For every algo, it's different. I'll show you the graph too. Okay. So, okay. So here, have a look at it. Okay. So for every algo, this is different. For I told you about 10 elements. I told you about 100 elements. I told you about 1,000 elements. So these are very general stuff. You actually don't need to go you don't need to really need to go into very deep to understand about this. This is giving you the computation time of a computation time of a big O notation at different types of elements. So I told you about, if you remember, is my screen visible properly or should I use a magnifier? Okay, sure. Is it visible now? I hope it is visible now. Okay. The moment I touch it, it's going. Okay, let me use my cursor. I hope my cursor is fine. Okay. This is very, very irritating. So O1, okay, we had 10 elements with us. The computation time is 1 second, 1 second, 1 second, or it can be 1 millisecond, or it can be 3 milliseconds. When it changes to O log n, it's 3 second, 7 second, 10 seconds or 10 milliseconds, and it is changing whenever this equation inside it, O1, I'll just call it O, it's a thing I do. O log n, the time has changed. After that, O n, the time has changed. The computation elements over here is 10, over here it's 100, over here it's 1,000. If you want to take a screenshot of it, you can take a screenshot of it, or whenever I'll share the notes of this complete thing, I'll zoom out a little. Yeah, this is different. How much should I zoom in? I don't know. Okay, this is the best I could do. So O n log n is something at what time on 10 elements, the time it is taking, or for 100 elements, the time it is taking, for computation of 1,000 elements, the time it is taking. So every time this big O notation is changing, there are different type of times it is changing. As we have seen in the graph, let me roll back and let me show you that. So the moment we saw in the graph, the new magnifier is very shitty. Yeah. So as we saw in the graph, that what happened then at this position and at this position, shall we get the slides for reference? Yes, you'll get the slides. So for this O n factorial, for this O n cube, it's a scenario, and this is O1. Okay. So you have to balance out your algorithm. You have to see your algorithm, how it's working, in what sense it is working in this manner. Either it's on O n factorial, then it is in its worst state. When it's working on O1, then it is in its best state. This is best and this is worst. And we always take worst case scenario. Okay. Okay. So next thing, I guess this was it And if there are something you really need me to cover about, I will do a really deep, like we will really deep down go to the part where we will understand completely what is happening. For example, in this worst case scenario, in O(n) factorial, what is happening? Your n is getting multiplied again and again with n, n minus 1, n minus 2, n minus 3, and it is going till it comes to 1. So the number of times when n, we are multiplying it with n, it is getting more complex. The number of times it is getting multiplied, it's getting complex. For example, if I'll say, what happens if I buy? So we used to have questions in our mathematics book. If you have done NCRT, there is always a crazy kind of guy who just go out and buy 100 watermelons. That kind of guy. So he bought 100 watermelons. That is fine with us. He brings on 1,000 watermelons. That is fine with us. Now that freak is going out and saying that I'm gonna buy 1,000,000 watermelons. So the n increases exponentially, and it is very hard for anyone to compute that kind of information. So similarly, that goes for an algorithm too. So different algorithms have different big O notations, and all we need to focus upon is that Big O cares about the worst case scenario. So in any kind of interview you're setting, all you need to ask is that should I do this into the average time and space, or should I do this in average versus worst? You should ask that. Should I take it out for average, or should I take it out for the worst case? Okay. So because whenever we are doing something, whenever whenever if you're seeing there is an algorithm, okay, there is XYZ algorithm, and what is happening in that algorithm, that from right to left it is traversing something, okay, and then from left to right it is also traversing something. So do you think that the algorithm will be okay? I got from right to left. Now I'll make sure that I remember what happened from right to left, and I'll come back left to right. That doesn't happen. It takes the same amount of computation whenever it is. It's not a human, right? If I have to remember some place I have gone, I will remember it. But the algorithm takes the same amount of computation when it is doing such kind of thing. Understood? And I need a yes gang. Is there a yes gang today? Do I have a yes gang? Yes gang, tell me. Sorry for being stupid. Yeah. So so there are times, okay, there are times when people ask me, Prakarsh, you told everything about n. You told everything about n. But what happens when there is one more algorithm which says 2n, or which says stuff like that? What should I do? So you remember I told you about significance and insignificance, right? I told you about insignificance. For example, at this point of time, I just I just faint in front of you. That is a very significant thing. You will forget about data structure and algorithm, and you would be like, oh, this guy was teaching us. He just fainted, right? So what happened to him? What is the reason he just fainted? You would be thinking that. So that moment, that is very significant to you. This process is going to be very significant to you. But the rest of the process where you are learning, that is not so significant to you, right? So this is how significance and insignificance is taken care of. So for example, in a scenario where is O n square plus 2n, okay? So you think, what should be the insignificant part over here? Obviously, n square. I'm kidding. It's 2n. 2n is something which is very insignificant, and it gets converted into O(n) square. See why I am telling you this, because in future, whenever we are doing a question, I'm going to make sure that I convert this kind of thing into this, right? So we would be taking different competitive programs. So I would be doing 100 questions for interviews, and I would be explaining how to work on algorithms on them. And I'm making a base here right now. So this base is going to help you crack those interview questions. And today we are going to do one interview question as well, if we are on time. So over here, O(n) square, it is getting converted into O(n) square. So what happens when we have O(n) cube plus log n plus 3n? What do you think? You can type down the answer in the chat section, and I would always be able to. Okay, so for example, this was something for input 1. Okay, n can be 1000 for a random array, but once we have to calculate it for multiple arrays. Understood? For example, when we have to calculate it for multiple algorithms at the same time, then what we are going to do? What we are going to do? M, if you take for 10,000 entries, it has. Okay, so it has 10,000 entries, and what do we need to do then? What do we really need to do then? You think of, so whenever such kind of scenario comes in your mind, it is obviously going to be O(n) plus m. Okay, and do you think that in a complex scenario, or in scenario like M square plus 2n, or a complex scenario like n factorial log m plus 2n? Okay, so we have these three kind of scenarios. So do you think significance and insignificance would work over here right now? Would it work over here right now? Do you think it's going to work here right now? Give me a second. I'll have a sip. What would be insignificant over here? So as you can see, over n is a different array and m is a different array. They don't have anything in common in just when we are calculating their big O. So we just can't say, okay, n is insignificant and m is significant. M is insignificant and this is significant. We just can't do that. So this complete notation comes to the play. This complete notation comes to the play, but you can remove stuff like, for example, if you have n factorial with you, you can remove 2n. No issues at all. You can just remove 2n, and you just can't have 2n. But because we have n factorial with us, we have log m with us. Okay, so this is how you take. This is how you actually take on something. So as promised, we are going to take upon strings right now. So what do you think is a string? String क्या होती है? What is a string? What do you think is a string, man? Answer I, but late IR, and the answer for that is n cube. Yes, the answer for that is O(n) cube. Boom. Thank you so much, Hina, for a right answer. Thank you so much. And after that, so over here, it's set of characters. Yes. Strings. Okay. Yes, a set of characters. Anything more? Anything more you want to add? You want to tell us about? Okay, so as you can see, there are different kind of languages. Okay, there is C++, there is Java, there is Python, there is JavaScript. Okay, there is Go, Rust, and the list goes on. Okay, so in strings for data structure, everything. So every language has a different interpretation of string. Every language has a different interpretation of string. So whenever you're taking a language, whenever you're working with a language, for C++ and Java, there is a different interpretation. For Python, there is a different interpretation. For JavaScript, there is a different interpretation which is similar to JavaScript. For this is similar to Java, and the list goes on and on. The list goes on and on. So why do you think why? I'll tell you in a bit that why these kind of mutation and immutation. I'll tell you the difference between that. So bye bye Corona. Okay. I really wish to do that, but okay. So this is a string. Okay. And this is a string, and whenever we see that there are characters, so these are characters, okay, and these letters are characters, okay. Somebody gave the answer that these are set of characters. You're absolutely right, and these characters, they are mapped. They are mapped. So you can see keyboard over here. The moment I type A, B, C, D, E, F, G, H, I, J, K, so these are mapped to something. These are very much mapped to something if you are able to see it. So the moment I type A, so this is a physical button which gets pressed, okay. This complete keyboard has a mapping, and this complete keyboard has a mapping of, we can call through either they have a ASCII mapping, and this mapping helps the computer to understand the moment I press A. So there are some binary, it has to be converted into the binary form in the end. So there are coding standards for it. So for example, if I have to take for A, it is 65. The ASCII mapping according to the ASCII mapping. So for an English character, A is on number 65, B is on number 66. So this is how this really works, okay. But for example, if I change it to a Hindi manuscript, or if I change it to a Chinese manuscript, the type of character mapping also changes. The type of character mapping also changes. This is basically a mapping happening over here. You can see the moment I type something, the moment I make an input, the input goes out to the computer and it says, okay, they have pressed A, and A means that, okay, A means 65, okay, just compute that and type, just show him A. Boom, done that. So this is done in very milliseconds of time. It is done in very short span of time, and it gets reflected over that. So over here, this one byte, this complete information can be taken into 1 byte, and 1 byte is part of 8 bits, okay. So and this string is a fixed width integer, okay. So for a fixed width integer, remember this word, fixed width integer. Not a fancy word, normal word, fixed width integer. It's gonna be fixed and it's an integer. That easy. So that kind of integer, or that is taken into a constant time operation. No matter what you do, no matter any key you press. For example, if I press A, the time it gets typed upon my system is gonna take the same time as you. You can hear the train. So it takes the same time as U, and it takes the same time as R, as E, as W, as Q. It's the constant time operation which is happening over here, right? It is a part of a constant time operation. The time is always same. Whatever I type A, same, B, same, C, same. It's pretty much the same. So you would be thinking that Prakarsh, what happens when we do different kind of operations over strings? What do you think are different kind of operations over string? So different kind of operations over string is something. The very first operation is, let me see if I have that pen with me. I'll take that. Okay. So the very first operation is traversing. What is traversing? Okay. So traversing is something you have a bicycle with you. Okay. Just mind me on my drawing. Just don't care about how I draw. And you have a bicycle with you, and you're on that cycle. and you have different positions, you have different loops, okay, and you are visiting them. So you are visiting them and you're seeing, okay, this is first house, this is second house, this is third house, and this is fourth house. You're not doing anything with that. You're not doing anything with that. You're just reading out the house's name, or you're just visiting that. Ki whenever someone comes to our colony, or whenever someone comes to a society, we're like, okay, we'll take you on a ride, and we'll be like, okay, this is this house. Ye Mehra ka ghar hai, ye Batra ka ghar hai, ye Sharma ka ghar hai. We do that. We do such kind of stuff, right? So traversing is something like that. You go out of your house and you see things, but you don't do anything with that. So what happens in traversing? You're not doing anything, right? You're not doing anything, and you're not doing any kind of operation. So in that operation, hey, shit. So in that operation, in that traverse operation, what do you think is very much constant? This is constant time. This is constant time. Nothing is changing. You have not changed anything. You have not changed the very much core to it. And okay, now here comes the play. Here comes the play that your mama says ki yaar, the Batra guys, they have done very nice garden work. Prakarsh, can you go and just get a photo from their end? And you get the photos from other houses too. So they have done very nice garden work, and we will copy from them. And they're like, I'm like, okay, mama, I'm gonna get the images for you, and I just go out, grab my phone, and I'm gonna like, okay, I have to click a picture of every house out of my house, and I have to bring that to my mother. That is something copy for me. So that is a copy operation. So what do you think? For copy operation, it's gonna take a standard amount of time. Do you think that? But the time is changing as the number of input, as the number of the houses increases. It's gonna take me more time, right? As if there are too many number of houses, and if I have to click off a picture of every house, the time is increasing, right? The time is increasing. Over here, I was not doing anything. I was just visiting them. I was just seeing how their houses were built. But right now, in this scenario, what is happening? Right now in this scenario, I have to make sure that I click the photo of each and every house. Now comes the play. So how many of you know about Kadi Patta? You know, there is a thing called Kadi Patta. Let me search that, what is called in English. But you know what is Kadi Patta? Curry leaves. Okay. Yeah. So do you know what are curry leaves? I'm gonna wait. I'm gonna wait for your answer. You know what are curry leaves. Okay. So there was a time my family didn't have. Kadi Patta is a very famous. Curry leaves are put in every Indian dish out there. Okay, so you put that in every Indian dish, and you're like, and your mama is like, beta, can you go and get some kadi patta? And the play over here is, so every house has a kadi patta's plant. Every house has that. Your house just ran out of kadi pattas, and yeah, dhokla, man, love that. My favorite dish is poha. So yeah, and so every house has a kadi patta, and my house ran out of kadi patta. Okay, and so I have to go to every house, man. So I'm a more fan of rasam. So I have to go to every house and I have to get a kadi patta. Okay, so that is a job for me. That is an operation for me. Operation kadi patta. Yeah, yes. Very well. I have a foodie students, and I like that. I like that. Okay, so so I have to get the kadi patta from every house because we are making a very great feast for you guys. So yeah, 15-20 guys, and you guys have to start eating that, and we have to get so many kadi pattas for you, and we have to go to every house, get some kadi patta, and I have to come back. Okay, the discussion, we can have the discussion later, right? So it's gonna take me the same time. It's gonna take me the same time over anything because it is something. Okay, so it's gonna take me the same time whenever I'm going to every house and getting the curry patta when I have traversed it. Okay, here is one more. Okay, so I'll tell you why I have wrote this and why this is over here. So when I have traversed it and when I have traversed the complete thing and I know what is going to be the size of the complete input, it's a 1. And when I have done all such kind of stuff and when I have done such kind of operations over thing, it gets changes into that same thing. Arre bhai. Okay, so it get, where were we? We are lost. No, we are not lost. Yeah. So over here, so as you can see, you're visiting every house, but you don't know how many houses are there. But the moment you have visited every house, now you know that if you traverse again or if you go through it again, it's going to take you the same time and it's going to take you the same kind of space in your algorithm. And the same goes for get. Now, if I have to do one more operation, for one more operation, so how there is a thing called mutability and immutability. Okay, every language has its own mutability and immutability. Understood? So that kind of operation is mutate. Okay, so you have to mutate, you have to add or change something. You have to add or change something. You have a string with you. You have a string with you. The string is very simple. Beta, get on the floor. Nee, we are not. Okay. Raise your hands up. The teacher says raise your hands up. Okay. But, and everybody sit down. Okay. So they're saying raise your hands up. It's a part of a string. And they're saying everybody sit down. That is also some other string. Okay. You have to mutate it to a point that it is the same sentence. Everybody raise your hands up and everybody sit down. Okay, so you have to change these two strings, you have to bring it together and you have to make a complete sentence. So you are mutating what you have with me. So all these words there, people ask me, Prakarsh, I don't know this, I don't know that, I don't know many of the stuff. Mostly, bacha, it is you understanding what that word really means. It's understanding the meaning of the word. If you really think what mutate means, just go and Google what actually mutate means. Mutation is something changing something. We have mutated it. So similarly, when we have mutated it, as I told you, for different languages, what we have with us, C++ is mutable. So green arrow means mutable. Java is, I'm sorry, immutable. Python is immutable. JavaScript is immutable. Okay, so these are immutable languages. So you can't change the string whenever you want to. But there is a scenario that you can change the string. There is a scenario that in questions when you're coding with Java, Python, or JavaScript, yes, you can actually mutate a string. Okay, so what happens when we really, so C++, I'm not talking about C++ right now, I'm talking about Java, Python, JavaScript. So when we have to change that, whenever for example in Java, what happens that whenever if I really want to mutate something, it copies the string. Okay, it'll copy the string. Okay, and for example, food is equals to dhokla. Okay, so for that operation, food is equals to dhokla. Now, as if you understand Python, food is equals to plus x. I have just made a mistake. X. So I have to add the number of dhoklas I have to make for you. Okay, so I have to add the number of dhoklas I'm making for you, and I have to mutate that into this. Okay, I have to add that. So this complete operation, this is an ON operation. This is an ON operation. See why I am really focusing upon the notations over here, because in last class people were asking me, Prakash, how did you come to this? How did you come to the conclusion that this is going to be ON square, this is going to be ON cube? How did you come to that conclusion? Why have you done that? So this is basically whenever we have an array with us, so this string would be broken down into the number of pieces of different arrays. Understand what is going to happen? So this string will be broken down into different pieces of arrays. Okay, so for example, for this string, this is going to be D H O K L A. This has been converted into a list or an array. Okay, list is for Python and array. Okay, so this is converted into this is splitted this string into an array of characters. This is array of characters. Okay, now when I have to mutate something, whenever I have to mutate something, I will copy the number of strings. I will copy that string in an auxiliary memory, and I will break that string into an array of characters. Now, if I really want to add something to this, what I really need to do is just add it to my array. Understood? Understood over till here? I'm waiting. Arun, Arun, if you really traversing find. Arun, if you really need to, if you have something to say, you can just reach out to me on any of those channels I have given for you. It can be Twitter, it can be LinkedIn. You can reach out to me anywhere if there is something specific you really want to ask me. So you got my point. You got my point that whenever we are changing a string, for example, it's dhokla. The dhokla string get converted into an array of characters. Okay, and then if we really want to immute something, and if we really want, if you really want to mutate something, then this is the only process that how we can mutate this complete thing. Understood? You can say yes or no, guys, because now I would be starting with arrays. We are short on time. Okay, cool. All I need is one yes, and then I can always move on to the next thing. Arrays. Finally, what are arrays? For that much amount of time, I was saying that array this, array that, list, structure, array. I was saying that, right? and you guys were saying that I told many things about how things are changed into array, how memory works and everything, every stuff. So here we have to focus upon how array works. Okay, how array works and what is array. Galaxy pen नहीं use करेंगे, we would. Okay, arrays. Okay, if I say array, does it ring any bell to you? So this is very fundamental DS. Okay. So this DS is this is the most important data structure and very fundamental data structure. And in terms of coding, it is very much used in every day-to-day bias. Okay, in every day-to-day bias, and you would be thinking that how an array is saved. 2, 3, 5. Okay. Yeah, surprisingly, this didn't convert into. Why this is not converting into? Okay, why it's not happening? But don't care about the drawing, because this is how memory looks inside, and this is how memory works inside. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just don't see this one. Okay, this is how memory looks. This is how memory looks inside. This is where whenever you'll go open your computer and you'll see that how memory looks inside. This is how it looks. So array are two kind of. So we have two kinds of array with us. One kind of array is static, and the other kind of array is dynamic. Okay, two kinds of arrays. Okay, so for example, how an array is written, if you can see 1, 2, 3. This is the array. Yes, this is an array. This is how an array looks. So this is basically a binary, like this gets converted into a binary number format. So this array gets converted into a binary number format, and this gets saved into this memory. Okay. So whenever it is getting saved into the memory, what happens with that array? That this array will see slots. So you had a question that how did I come to that 8-bit, 16-bit, 32-bit elementary operations? If you remember, I was telling you how many operations it's going to take part of. So this, for example, this is a 64-bit operation. Okay, this is a 64-bit operation. This 64-bit operation is going to take how many slots? As there are, for every operation consists of 8 bits into 3 selections. So it's going to take 24 empty slots. So if this is your complete memory, not a very good drawing. I don't know, this generally gets converted into. Go away. So this gets converted into a magic over. So this gets converted into this memory, and you need 24 memory scapes to save this kind of data, right? You need 24 memory to save this array inside, right? So whenever you have to save that, whenever you have to save this, you need 24 memory empty slots. You would be thinking that any 24 memory slots or specific 24 memory slots. So whenever it is saving something, it will only take which are in sequence. For example, if in any case this memory slot is filled, okay, so this complete sequence will fail, and it is going to look for another memory slot which is in continuation. Understood? Understood what I'm trying to tell you guys? Let me. LinkedIn ID. What is my name? Say my name. My name is Prakarsh Pathak. It's already you can find me on. I'll give you my handles. My art. It's PRAKARSHPATHAK0. This is my Twitter ID. I generally use Twitter. You can you can always reach out to me, and I would always answer you on Twitter. Or you could also search this on LinkedIn and you can message me if you have any kind of doubt, and I would answer you. Okay. So coming back to the point. For example, your memory was going to save your array was taking 1 comma 2 comma 3. That 1 comma 2 comma 3 on it's a 64-bit operation. That operation is taking 24 memory slots. It's taking 24 memory slots. And it's going to take that 24 memory slots, and this is how memory looks. This is our memory, and this is how it is going to save in the memory. This array is going to be saved in memory in such way. Okay. So when, for example, if there is a memory, if there is a scape that it gets, this memory is already filled up. So what will happen that it will not take this memory, and it would take something which is in continuation. It would not take something which is not. It would not take something which is not in continuation. So it will always take up the space. It will always take up the memory which is always there in continuation. Understood? Understood. I have the Sunday blues with me. Sunday, I'm like, I'm a bit gloomy. I'm a bit letharged, but yes. But Sundays are very very if you really want to have a conversation with me, you can tell what you did on your Sunday. What did you learn? Is there anything good you have learned? So coming back to the point, static array. Because if I would have been in person, we would have done a lot of fun. This is just like speaking to a computer. Hi Lenovo, what did you learn today? And so it's very, sometimes it's very lonely. So yeah, so coming back to point again, static array. Okay. And to those people who think that we are not going to cover the syllabus and we are not going to do that, don't worry. We are going to take increase the number of classes if it doesn't work like that, because I really want you to understand every piece of information I have with me. So this has a specific length of array. This has a specific length. If the array is going to be n, it's going to be n. Okay. And let's take an example that all the arrays in the world are static arrays. Okay. All arrays, static arrays. Okay. And this static arrays, for example, let's take an example. Array. Okay. And the moment I go fetch for an element inside an array, and I'll say array 2. Okay. So what will happen? For example, I'm like array 1 2 3. I'll go array 2. The array will be like, okay, 3. Yeah, array will give you the information just like that. It's very basic and it's very instant, because it's a very basic thing going on, because it knows that where the memory has been saved. As you remember that when we have plotted this complete thing, kya ho raha hai bhai? Did I press something? Okay, we just came to a point. Okay, this is going to help us. Okay, so I told that we have saved this array with us. Okay, this array was saved in this. The fuck? Give me a second, guys. I'm really sorry for this. I'll just figure it out in some time. Go to hell. Go to hell, Windows. Okay, so why is this not working at all, man? Okay, 1, 2, 3. Okay, this is an array, and this array was saved in our memory. Okay, and this took 24 memory brackets of this memory. Okay, it did that. So now in a static array, I'm really sorry for the problem. I will solve it. In a static array, the computer knows that where you have saved that, where you have saved it. It'll know that moment that okay, it has been saved over there. The moment I have to fetch something, if I'll say array2, okay, the moment if I'll say something, it will be really instant. Why it would be really instant? Because it knows that where that memory has been saved, where that information has been saved, and all it needs to do it, fetch for it, and it'll get that and it'll give you the output. So it's super instant. It's super instant. So it knows the memory address, and you know that this is a fixed width integer. This is a fixed width integer, because you remember at that time, whenever with strings as well, what was happening that we were converting it into an array, and then we were saving it inside a memory. Similarly, with this array, we have saved it inside a memory, and this is a fixed width string. And this fixed width string has always a type of memory, has the number of memory slots it is always going to use. Understood what is happening over here. So whenever in a static array you are going to fetch something, it's going to be very instant and it's going to be very fast, because the computer knows where you have saved that. So I guess we are a few past. Multiple classes with limited time will be a wise choice. Yes, I'm also thinking that. Increase the time duration. I will take that into concur. We are thinking of 1.5 hour session with you guys. And I guess from next time, either the session is going to be 1.5 hour, or the session is going to be 2 hour long. We can do that. We are thinking to do that. And to whomever, if you're not getting the mails, please drop me a mail at prakarsh@skillenza.com. Please drop me a mail over here. Okay. Please drop me a mail over here if you're not getting any time, because we would be sending you the assignments and we would be sending you the material for this. So for that, you have to please send me your mail over here, and I would send you the related stuff to that. Okay. Thank you, guys. Thank you so much for coming in. And the class will be tomorrow. And we will be taking care of static arrays more. We would be taking care of static arrays, and then we would be moving on to dynamic arrays. Bye bye. Bye, Toldo.